Well, I start recording and let's start the lesson. I share my screen. First, let me show you the simple program. On practice, you consider input and output statements. We use cout to output some message to the screen. Not only message, but maybe some number, the result of computation. And we use cin to enter numbers from the keyboard, and this simple program allows us to enter two numbers A and B and output the result of computation A plus B. Two and 3, and the result 2 plus 3 is 5. I can enter here negative numbers, positive numbers, -3 plus -4. What is the result? -7. Okay, if I type here divide A over B, not plus B, but A over B, and I enter again 3 and 4. What I will see on the screen? 3 and 4. 3 over 4. What? 0.75. 0.75. Right. 3 over 4 is 0.75. Okay, but you see that I use two different data types here, integer and float. And today I'm going to talk with you in details about data types. Of course, you more or less understand that int is for integer numbers, float is for real numbers, but let's consider it in more details. I open the presentation, the slides.
Hello.
Data types in C++. The notion of data type is one of the most important notions in programming. And in C and C++, any information object must be declared with concrete data type. It is a main difference, one of the main differences between C and Python, for example, because in Python you can declare an object, you can declare a variable, and Python understand what is the type of this variable in the course of program execution. But in C language, any information object must be declared in advance, and you should specify the concrete data type. We can declare constants, the information objects which do not change during the program execution, and variables, the information objects, the value of which may be changed during the program execution. How we can change the value of variable? For example, by means of assignment operation or input operation, if I write C in A, I change the value of A. If I declare, for example, one more variable C, and I type here C assign A plus B, the value of the variable C will be changed by means of assignment operation. And here I can output the value of C. Now 3 plus 4 is 7. But what is data type? How to give a definition of data type? Of course, we say integer number, real number, maybe natural numbers. Let's consider just the numeric types. This question maybe is not related with programming. What kind of numbers do you know? Except integers and real number. Integers, real. But do you know any other numbers? Not in maybe not in programming, but in mathematics. Epsilon is just a notation for a small number. Pi is also is one concrete real number. But I ask you about the class of numbers, the set of numbers. Z. But what is Z? But these set of numbers, we called it integers. Z means integer. Negative, positive, and zero. Natural, excellent, natural numbers. What is it? What is natural numbers? 1, 2, 3, 4, 5. Maybe include zero, but maybe. In some cases we include zero, in some cases we not. But only positive numbers called natural numbers. 1, 2, 3, 4, and so on. Okay, if we consider these numbers, it's hard to write on this board, but maybe I try to write not on a board, but in Visual Studio here as a comment. Come in. Okay, natural numbers. 0, 1, 2, 3, 4, 5, and so on. You told about Z, integer numbers. Integer numbers are -2, -1, 0, 1, 2, and so on here, and so on here. Okay, if we consider these two class of numbers, what operations we can apply for these numbers? What operations we can do with the numbers, with this type of numbers? Addition, multiplication, addition, minus, but pay attention. If we consider subtraction, minus. If if we subtract two negative or two natural numbers, we can go outside. We can get the negative number. So for natural numbers, we can apply why everything, just addition and multiplication. Because if we apply subtraction, we can get negative number. For these numbers, we can apply plus, minus, and multiplication. Plus, minus, and multiplication. We cannot apply division, because if we divide two numbers, we can go out of this class. So we can get another number. So this simple example shows you that the class of numbers, or in programming, we call it data type, is closely related with operations that we can apply to this class of numbers. For natural numbers, the set of operations is plus multiplication multiplication. 2 times 3 equals to 6. In mathematics, we have 4 operations: addition, subtraction, multiplication, and division. For that, for integer numbers, the set of operations includes minus, but we cannot apply division. Well, in mathematics, not in programming, but in mathematics, there is one more class of numbers. Maybe you hear about it. We called it rational numbers. Rational numbers that can be represented as a fraction. Rational numbers that can be represented as a fraction m over n, where m is from z and n is from n. In this case, when we consider this class of numbers, in this class we can apply division. Well, here m is from z and n, yes, from n. N is from n. Well, the notion of class of numbers or data type, you see in these examples, includes two sets: set of values and set of operations. And when we define a data type, we should strictly define the set of values, what values we can use, and set of operations, what operations we can apply to these numbers. So when we consider so-called abstract data type, we can define it as a set of values and set of operations carried out with these values. And we can define it as denote it as a tuple m and sigma, where m is set of values and sigma, this sign, set of operations. But abstract data type, I can write these numbers on a paper, on a board, but not, I cannot use this abstract type in computer. When we discuss about data type that is implemented in computer on some real machine, we should propose a method for representation for the values in computer memory. And we can implement the operations from the set of operations as some machine command. As a result, the program or machine data type can be represented with three sets: set of values, set of operations, and a storing structure. So the method of representation and processing data in computer. So we should not only describe the set of values and set of operation, but we should introduce the storing structure, how these numbers will be stored in computer memory, how these operations will be implemented. In C language, there exists so-called basic or system or standard or predefined and derived data types. So the types constructed by programmer. One set of data types is already defined in C, and another data types can be constructed by programmer manually. The basic data types already exist. So their set of values and set of operations and storing structure are already implemented. For example, these signs are used for notation for the numeric data types, for the operations for the numeric data types. But for derived data types, the data types that are given, that are defined by programmer, their operations must be defined manually. Well, this is a general classification of data types. All the data types are divided into basic and derived data types. In turn, basic types are divided into void or empty type and scalar types. Scalar types are divided into integer valued and real data types. And here also we have a set of different data types, but the most important for you are two of them: int for integer numbers and float for real numbers. What is the meaning of derived data types we consider later. And we should use the keyword that defines this data type when we declare a variable. So when we declare a variable, we must use the identifier of a data type. The data type and the name of the variable. So this is the example how we can do it in a program. Float the data type, A, B, and C identifiers that correspond to the variables of the type float. If I change here data type for int, these values becomes integer. Well, about the variables and constants we spoke on the previous lesson. Now let me switch to the next slides, next presentation. Well, we already discussed that the machine or computer data type includes 3 sets: set of values, set of operations, and the storage structure. Storage structure. Well, and let's discuss in details about the integer data types. Well, I skip these slides that are that discuss about the storage structure. Maybe we come back to these slides later. And well, when we are talking about the numeric data types, the numeric data types are divided into integer valued types and real types. Integer valued are the numbers, only integer numbers. Real types, the real numbers. And the integer value types is divided into unsigned types. It means the types without sign, the types, the value of which can be only positive numbers. And signed integer types, including both negative and positive values. Actually, we can use different notations for the constants of the integer types. We can use decimal, octal, hexadecimal notation. So we discuss about different notations later. And integer and real types have several modifications depending on the size of the value set and as a consequence the size of memory required for data storage. Well, altogether there exist 8 integer value data types, and the value sets of 4 types include only non-negative numbers. We called it unsigned types, and other 4 types contains both negative and positive numbers, and also called signed types. Within signed and unsigned types, they differ in range of representation and memory size needed for data storage. Well, let's consider maybe the most useful for you and the most important integer value type, int. And we use int to denote their integer numbers. Integer numbers with their sign means that integer can be negative, can be positive. But what is the range of representation of int? Can we store here any number or any large? I can say, can I store here very, very large or very, very large positive or very, very small negative numbers? No. Positive. No, the answer is no. There is a fixed range of representation. And here you can see their constants that correspond to the largest integer number that can be represented in computer and the smallest integer number that can be represented. Let's check this fact. Suppose that I declare the integer number and I assign this value. What is it? What is this value? It's 2 milliards, 147 millions, and so on. So 2 billions, 147 millions. And after that, let me just output the value of A to the screen. A and here A. Extremely simple program. I just assign the value to the variable A and output this value to the screen. Yeah, we see that we see these values. We see this value on the screen. If I write here, for example, -1, what will we see on the screen? 6. This number and 6. This number and 6. Okay, if I write here -2, we will see on the screen with this number and 5. Very simple. But what happens if I write here A plus 1? This number and 8. No. Do you see these minus? Do you see this minus? Or even if I type here +2, 109. No. We will see on the screen some negative number. Why? Why we see it?
Because I think she has.
Okay. it's it's question for me to answer this question for you, because this number is the largest.
But the
maximum number, the maximum number that can be represented in integer. If I add at least one, we go outside of the range and the result will be unpredictable. We even can get negative number. So very, very large positive number plus another positive number, and the result is negative. Because we are go out of the range of representation. This number is the largest number that can be represented in computer. In the type int, of course. In the type int. Well, a plus 2 go out and we will see some other result. A plus 3 we see some unpredictable result.
It starts from the bottom and
well, and also, what is the smallest negative number? This is the smallest negative number that can be represented in the type int. This is the smallest number. Well, of course, you should not remember these numbers in mind, but you should keep in mind that there is a range of representation, and you cannot represent here very, very small negative and very, very large positive numbers. Approximately 2 billions and 100 millions. So 2.5 billions you cannot represent. Well, this is the smallest number. This is the smallest negative number. Let's output this value to the screen. We see the correct result. If I output here +1, a plus 1, this negative number +1, yes, we will see this number and 7 in the last position. +2, 6. +2, we see 6. But what happens if -1? Again, as far as this number is the smallest, when we subtract the number, the result will be unpredictable. We will see positive number. Okay, so negative minus negative, positive, because the range of representation. If I subtract here, for example, -2, we see here again positive, for example, -20, also some positive number. So the result will be wrong. Of course, in your programs that you will consider on practice, you always will work inside this range. But for the future, you should always keep in mind that there is a range of representation. Okay, but this example that I show you, it corresponds to the type int. This type is signed. It means that for the signed type, I can store both negative and positive numbers. And the type int, it corresponds to mathematical type Z for negative and positive. But I can write the special word unsigned before int. And in this case, this data type becomes only positive numbers, starting from 0. The keyword unsigned, and it means that now the value of A
0.
is on the value of the variable A can be only positive. Only positive numbers. Well, and if I write, for example, A equals to A plus 1, and after that I output to the screen, we see 1. We see 1. Well, but if I write A equals to A minus 1, but minus 1 for the signed type, for the type that can store negative number. If I write here this special word unsigned, it means that A, the range for the variable A now starts from 0. And the variable A cannot store negative numbers. We see on the screen very, very large number. So again, the result is unpredictable. The result is unpredictable. If I subtract minus, if I subtract 1 from the unsigned A, when A equals to 0, I get some, I don't know, number. For example, minus 10, also I'll get some very strange result, large positive number, because A is unsigned. A corresponds to N, the real numbers. But if I add plus 10, I see 10. It's okay. It's okay. It strictly corresponds to the type, natural number. I told you that I cannot apply subtraction for natural numbers, because when I subtract two natural numbers, I can go outside the range of representation. The unsigned int corresponds to natural numbers. And also, let me switch to the presentation again. Also, the smallest number for unsigned int is 0. But what is the largest number? The largest number is written here, this one. It's also the largest number for the unsigned int. This is the largest number. If I, for example, write A minus 1, we will see on the screen this number and 4. This number and 4. It will be okay. This number and 4. But if I try plus 1, I don't know what I will see on the screen. The result will be unpredictable because we go out of the range. Go out of the range of representation. If I plus 10. I don't know the result. I don't know the result. So again, these examples I show you only to stress that we cannot represent in computer very, very large numbers and very, very small numbers. Any data type, including this type int, has a range of representation. Special range for every data type. And for int, this range is approximately 2 billions. For unsigned int, this range is from 0 up to 4 billions. This range, this number depends on representation of integer number in computer. And this representation in terms depends on a binary system of notation. Maybe later we discuss about binary system. Now just as a fact that this number equals to 2 in the power 32 minus 1. It's written also in my presentation that the range of representation of integer unsigned int starts from 0 up to 2 power 32 minus 1. And the range of representation for the int, it equals from 2 up to 2 power 31 minus 1 and minus 2 power 31. From this number up to this number. Well, if you want to remember the range of representation, you should not remember this large number. You should remember just 2 power 32. 2 power 32. And here 2 power 31 minus 1. 2 power 31 minus 1. Well, maybe just a small comment that there are another data types that can be that can be used with the keyword short. This keyword defines a small integer number, the short number with a small range of representation. This range is written here, minus 32 thousandths up to 32 thousandths for int, and from 0 up to 65 thousandths for unsigned short int. Just as a remark that instead of int, you can use short int. For example, when we can use short int. If you know in advance that your program will work only with the small numbers, not greater than 32 thousandths. In this case, you can use short int because this is the largest number that can be represented in short. But what is the difference between short and int instead of this range of representation? The difference is in the number of bytes. number of bytes in computer memory. For short, we use 2 bytes, and for int, we use 4 bytes. And in some cases, imagine that you write an application for example, for some mobile device with very small amount of memory. Smartphone or maybe a smartwatch. In this case, these 2 bytes can play a great role. For example, if you use int, you will you should allocate 4 bytes. And for the short int, the amount of memory will be 2 times smaller. And if you allocate the memory not only for the one number, but for maybe for 100 numbers or 1000 numbers, the amount of memory can be considerable. And this range corresponds to 2 power 15 minus 1. Well, maybe I don't want to go into further details. I just want to stress that instead of int, there are several another integer value data type, like short int or unsigned short int. Unsigned short int, we can use this type for small positive numbers. For small positive numbers from 0 up to 65,000. From 0 up to 65,000. And in your case, in your programs, of course, it will be enough to use int in any case, because the range of int is rather large, plus minus 2 billions. And it will be enough for you to use it in your programs. But again, you should remember that there are another data types with different range of representation, with a different number of bytes for storing. But for int, you should remember the range, more or less, plus minus 2 billions. Okay, and let me skip the definition of constants. It's maybe it's not very important. It's not very important for you. We come back to this later. Now, a few examples of operations with integer numbers. Well, if we consider integers in details, let's discuss about operations. I already told you the typical operations, plus, minus, that corresponds to addition, subtraction, multiplication. But what about division? Can we divide two integer numbers or not? But what will be the result? Let's consider some example. Let's consider two integer numbers. Let's consider the simple example. Let me declare two integer numbers A and B, right? And the third number C, and let me assign C equals to A over B. This is a very simple example. What will be the value of C? Yeah, the value of C is 2.
It's sales.
Or the value of A, of course. I should change. The value of C will be 2. Okay, but what happens if I change, for example, A to 5? What will be the result? 5 over 2.
And we will execute it.
The real result of this operation in mathematics equals to 2.5. But here the result will be 2. The result will be 2. This result corresponds to the integer part of the result. What will be the result of the division 5 over 4?
1.
The result is 1. Because the real result is 1.25. 1.25, the real result. But here we will see only the integer. Well, but if I write something like 5 over 6, the result will be 0. Because the integer part of the result, integer part of the division 5 over 6 is 0. And this will be true even if I write this division here. 5 over 6 will be 0. Let me write here C and C out just some result. And here just an expression, 5 over 6. 5 over 6 will be 0. It seems strange for the first view, yes? But computer consider the number 5 as an integer number and the number 6 as integer number 2. That's why the result of division 5 over 6 will be 0. Well, I think we discuss about the real number maybe next time, but some comment about real numbers. But how to get the real result? How to get
Roots.
But if for example, I don't want to use a data type float. I want to type 5 and 6. Can I get the real result? Yes. Yes, I can, but how? I must somehow tell the compiler that this 5 is not integer 5, but the real 5. And this 6 is not integer 6, but the real 6. And formally, I can put here 0.0. This is a great difference between 5 and 5.0. In mathematics, when you write this number on paper, there is no difference between 5 and 5.0. But in programming, there is a difference because 5 is integer constant 5 and 5.0 is a real number. It's a real constant. The number with fractional part. And here 6.0. When I write 5.0 over 6.0, the result of this operation will be real. And we see the real result, the real answer. Oh, yeah. Handle? No, no. Handle means end of line. Suppose that I delete this end of line. What happens? This message and this message will be output to the screen in single line. As a single line. C equals to 0 and immediately after this we will see 5 over 6. To separate these two messages on a separate strings, I must write here end of line. So end of line means handle means the end of current line on the screen.
I don't understand this part. Can you explain again?
End of line?
No, this why it will be different when we write
Okay.
5-0.
Okay. Now we are talking about integers, integer data types. But later we will talk about the real data types. And when we write just 5, it means the integer number 5 and integer number 6. In this case, this operation will be integer, the integer part of the division. 5 over 6, or more simple, just 1 over 2. What is the real result of 1 over 2? 0.5. And the integer part is 0. And in this case, we will see on the screen only integer part, 0. We will see 0. But if I type here 1.0 and 2.0, I tell the compiler to consider these numbers as real numbers. And in this case, this division will be real division. And the result will be real. The real result 0.5. And we see on the screen that 1 over 2 equals to 0.5. Well, just as a fact, if you want to get the real result, and if you use a constant in your program, always type the decimal point, 0.0. Yeah.
-1.
It's just a comment. It's a comment. I can delete it. It's a comment from a previous example. Any line that are colored with a green color here and here are just the comments. Just the comments that are skipped by compiler. Well, any other questions?
No, thank you.
No. Okay. Well, So this operation, division, will be integer division if both arguments, both parameters are integers. If the parameters, if the arguments are real numbers, the result will be real. This division will be real. But for the integer numbers, there exists one more special operation that is denoted as ampersand. Oh, so not ampersand, of course. Sorry. Percentage. Person sign. And the meaning of this result, or meaning of this operation, is also related with integer division. The meaning of this operation is the remainder of division. Suppose that I divide, for example, again, let's consider simple example, 4/2, right? 4/2. What is the remainder of this? 0. So C, the remainder of this operation will be 0. Five over 2. It's not a remainder, it's a fractional part. But in mathematics, what is the meaning of the remainder? It means that integer division 5/2, the integer division, I represent 5 as 2 times 2 plus remainder. This one will be the remainder. If I consider here 5/3, what will be the remainder? 5/3 is 1 times 3 plus 2. So the result of integer division will be 1 and the remainder will be 2. So in this case, C will be 1, but if I consider operation 5/3, the remainder will be 2. If I consider 5/4, what will be the remainder? 1. It's 1 times 4 plus 1. 5/4, the remainder is 1. For example, 7/4, 3, because 7 equals to 1 times 4 plus 3. Let's check.
But we can't do 6 times 1 plus 1.
6 times 1 plus 1, but I divide 7/4.
Yeah, sorry.
Not 7/6. In the case 7/6, you are right.
Okay.
It will be 1 times 6 plus 1.
Mhm.
Okay, 7/4. But let me here output two numbers, the result and the remainder. The remainder equals to A person sign B, and the result equals to A/B. In this case, I can output result equals to res and remainder equals to rem, and 7/4. The result is 1 and the remainder is 3. Maybe the most simple way how to understand it. Let me output the expression like this. Let me output the expression like this. How to output this expression? What is this number in my case? A. Okay, let's output A. After that, I want to see on the screen this message. What I should output? The equal sign. A equals to, then what is 1? 1 is the result, A over B, equals to result. After that, I want to see star, right? I output star on the screen. Next. No, 4. Right, 4. B, right. B, then plus, and the remainder. So we have here this large output statement. Let's check it. Let's check it. Let's consider. Yeah. Right. We see on the screen that 7 equals to 1 times 4 plus 3. Let's check your example. 7 over 6, right? 7 over 6 will be 7 equals to 1 times 6 plus 1. For example, 12 over 6. What will we see on the screen? 2 times
6, 0.
Plus 0. The result is 2. The remainder is 0. Because 12 is divided over 6 without remainder. The remainder is 0. If I can write here, for example, 15, we will see again 2 plus 2 times 6 plus 3. Very simple example, that very simple program that outputs to the screen this formula for the numbers. Well, any questions?
No.
About this example, about this program? Well,
It's very interesting. When I understand, I feel like really intelligent person.
okay. What you should remember from these lessons, from this example, that int has a range. Plus approximately plus minus 2 billions. Well, for int, we have some operations, usual operations with their usual result, addition, subtraction, multiplication, and 2 special operation. Division is not a real division, it's integer division. We have the integer part as a result, and special operation of getting the remainder. In some cases, this operation is very useful. For example, if you want, imagine that you enter the number from the keyboard. Let me comment this part of the program. Let me comment this part of the program. And let me write here input statement for A. I enter the value of A from the keyboard. And after that, suppose that I want to output to the screen the reminder. The reminder A/2. But what? 6? No. Again, person sign. But pay your attention that I write here input statement. I don't know what number I press on the keyboard. Cin, this is initial value, but this initial value will be changed when I enter the number from the keyboard. And the result will depend on the user input. But the question is, what will be the possible result of this program? What can I see on the screen? Can I see 3? Wrong answer. Again, can I see 3? Reminder equals to 3 in this program. If okay, you didn't understand. Okay, suppose that I enter the same number 15. What I will see on the screen? 1. Suppose that I enter 14. What I will see on the screen? 0. Reminder is 0. Suppose that I enter 11. 1. 10. 0. But my question, can I see 3 on the screen? Of course. What number should I enter to see 3? 17? One. I try to get, I output the reminder when I divide the number.
Just pair and amper numbers.
We can see on the screen only 0 and 1, right? I cannot see as a result 3. I cannot see as a result 2, 4. We can see on the screen as a reminder. As a reminder, only 0 or 1. And in this case, this result can be used to check. Is this number odd or even? Do you know odd, even? Even and odd numbers? Of course. What will be the result? What will be the reminder when the number is odd? And when the number is even? 1. So 2 possible cases. If the number is even, for example, 9, the reminder is 1. If the number is odd, 0. So this operation can be used when we imagine that we want to check. Is the number odd or even?
I don't understand.
Okay. This operation gets the remainder when we divide some number over 2. Yeah?
Yeah.
What will be the remainder when we divide 5 over 2? 5 over 2. The remainder is 1.
Mhm.
6 over 2. Why 3? 3 is a result. But the remainder is 0. Because 6 can be divided over 2 without remainder. Remainder is 0. 7. 1. 8. Why 1? 0. 8 over 2. 0. 9.
0.
1.
Почему 1?
Почему? Потому что 9 делится на 2. 9 не делится на 2 без остатка. 9 is not divided, cannot be divided over 2 without remainder. When we divide 9 over 2, 9 over 2.
Ah.
9 over 2 and the remainder. The remainder is 1. The result, 9 over 2, is 4. The result, 9 over 2, is 4. But the remainder is 1. When we enter 10, 0. Enter 11, 1. So this operation, we can use it to check, is the number odd or even? If the remainder is 0, or the remainder is 0 or 1. Well, later when we consider conditional statements, conditional statement if, we can work with this situation. We can output the answer on the screen. Is the number odd or even? Well, more questions?
No.
No. Well, our time is more or less over. We have just 3 minutes to the end of the lesson. Now I stop sharing my screen. And I stop recording. After the lesson, I will send you the video file with the